Tonight I'll be talking about energy and water efficiency in Strata and what changes can be made to improve the sustainability of common areas, solar as a sort of side thing, energy saving certificates, and I'll touch on water as well. I won't go into the detail that we will look at for energy. And I must admit, I apologise. Some of this stuff on this slide is not 100% relevant to this. I'm reusing something. So, very quickly, just about me. I've got a Bachelor of Engineering, of Environmental Engineering actually, and I've been working in the electricity industry for 18 years. I started in coal-fired power stations back in 2000, and was working in transmission and distribution for several years after that. And then I started Sustainability Now, looking at energy efficiency in 2009. And thanks to Christine over there, I have been specialising in Strata since soon after that. So about eight years in Strata now, I think. So what are the key contributors to electricity consumption or energy consumption in a Strata building? Common area air conditioning is probably the biggest one. If you have a large centralised air conditioning system that's metered through the common property, that's probably going to be far and away your biggest consumer, especially things like chillers. And then after that, condenser water plant is probably one of the biggest ones. Your second one, car park ventilation, but also just general ventilation of your other spaces, so your corridors and that sort of thing. Also, if the developer who constructed the building has an interest in ongoing operation and maintenance of the building and therefore paying the electricity bills, then you're likely to have higher quality, lower energy consuming plant installed. But most don't. Once they have sold the building, they walk away and have no more to do with it. So in that case, it's cheapest available technology meeting the minimum requirements. Older lighting technologies, we're not seeing as much of that anymore. Swimming pool heating, and in some cases, the age of the building. It's strange. You might think older buildings might be more inefficient, but it's not necessarily the case. I think a lot of newer buildings can be much higher consumers of energy. And the simple reason for that is just that they've got a lot more bells and whistles installed, more automation, more comfort level stuff. Whereas, if you think about a really old building that's 30 or 40 years old or something, it's not going to have a lot of lighting. It probably doesn't have a lot of ventilation, and I guess they did things a little bit leaner back then. So the biggest consumers, again, common area air conditioning. Other ventilation, so bathroom and kitchen ventilation, car park ventilation. Car park ventilation, if it's meeting the Australian standards or the minimum requirements of the Australian standards, can be a big user. So if it doesn't have carbon monoxide sensors or carbon monoxide monitoring to control that ventilation, and it's meeting the requirements, so it's running 24 hours a day, 7 days a week, that's a big consumer. Lighting, lifts, pumping of water around the place, and miscellaneous motors. This is just a really general one, and it changes from building to building, but this is just a very general sort of overview. So what can you do to improve that efficiency? And there's lots of low-hanging fruit there, and the first one is really just a cost thing, the electricity retail contract and network tariff. So it's essentially just understanding how you build for electricity in the first place, and taking advantage of peak, shoulder and off-peak billing, and also like KVA demand charges and that sort of thing, just knowing how that works. I've had a few buildings recently who had the mechanical services contractors in there testing their plant, which is great. It's good to see that sort of thing, but unfortunately, they were doing tests on large fans and that sort of thing between 2 and 8 p.m. Monday to Friday, which is when you build that's your peak billing period and when you build the KVA demand. So they were inadvertently costing their clients a lot more money by testing those items of plant. So just being a little bit smart about how you use your electricity. T8 fluorescent lighting, like basically these things up here that we've got, there's still heaps of those out there. Not as many as there used to be, but that's converting those to an LED or even a more efficient fluorescent, and integrating sensors where you can. So if the light doesn't need to be on, or if it doesn't need to be as bright as it is at full power, having some sort of sensor control over that lighting. Halogen downlights, they're almost non-existent now. I haven't seen any of those in a few years now. It's pretty rare that you see them. Actually, no, sorry, I lie. I did see some last year. So they are still out there, but there's not many around anymore. As I mentioned before, putting carbon monoxide sensors on your car park ventilation system. So the Australian standard says that those car park ventilation fans need to run 24 hours a day, 7 days a week, unless you can show that the air quality in that car park is at a certain level. So it's very unusual that you do see a car park where those fans are running like that. Normally they're on a timer or they're switched off completely. But putting carbon monoxide sensors on there is a risk-based approach. So essentially the fans need only run when carbon monoxide levels reach 9 parts per million or more. So coupling that with variable speed drives on there, so that when the fans do engage, they only engage at a low speed, so that just the minimum necessary to clear the air and then move on. So again, variable speed drives on pumps and fans that don't need to run at full speed all the time. With centrifugal fans and pumps, it's not a linear relationship between speed and power. So reducing the speed of that motor that's controlling that pump or fan by 20% could result in a 50% electricity saving. So that's a really easy one. Power factor correction, that's again just I guess it doesn't save a lot of energy over time, but it saves money. And I'm seeing less and less of an issue as technology improves. There's less inductive loads in buildings that cause bad power factor. So it's probably another topic that's not really worth touching on in too much detail here. But overall, we're pretty consistently seeing 10 to 40% reduction on average in energy consumption in these buildings. But in some cases, if you've got a really poor performing building, up to 90%, which is awesome when we get those ones. That they're getting rarer and rarer. As I mentioned before, electricity tariffs, again, take advantage if you can of those time of use tariffs, so peak, shoulder and off peak. The peak billing period is something to be very wary about, between 2 and 8 p.m. Monday to Friday, or actually it's working weekdays. So if you've got a public holiday, then that doesn't count. That's not a peak period. Also, demand charges. We talked on that before. So consumption, which is how you build at home, is billed in kilowatt hours. So a motor, for example, of 1 kilowatt running for 1 hour is 1 kilowatt hour of electricity, of consumed electricity. But also in bigger buildings who are on higher tariff rates, on EA 305 and higher, or EA 302 and higher, you're also billed on demand. Which is, for that same 1 kilowatt motor, it's the 1 kilowatt of instantaneous demand that's placed on the network. So just understanding how those tariffs work is very valuable, and there's lots of savings to be made there. And I find fairly regularly as well that a lot of clients, or I wouldn't say a lot, I suppose, but sometimes clients are on the wrong network tariff. They're actually on a higher network tariff than they should be, and typically, or generally speaking, the higher you move up a network tariff, the more it costs in daily charges and that sort of thing. So enabling those guys to drop back a network bracket will save, for example, like EA 302 to EA 305 is about $4,500 to $5,000 a year just in network charges. So that's a nice one when you see those ones come up. And I guess I'm, you guys know all about this. the simple ways to reduce electricity consumption or save electricity is, number one, reduce the hours of operation if you can. Turn things off when they're not in use, using timers and sensors, and reduce the wattage or the demand for electricity from those things, and replacing that with more efficient technology, retrofitting, and just making sure that those items of plant are maintained well. Gas, in residential strata, the main users of gas are typically domestic hot water systems, but also swimming pool heating. It's very common for swimming pools to be heated with gas heaters. Any hot water pipe work that you've got, obviously insulating that, maintaining the plant, checking it regularly. In terms of swimming pool heating, swimming pool covers is the easiest and most cost-effective way to reduce gas consumption. Basically, if you've got a swimming pool that's uncovered and it's heated, it's just radiating heat out into the atmosphere and just wasting that heat. Again, reducing thermostat temperatures within reason, and in some cases preheating the makeup water that goes into those things with solar or some sort of heat exchanger or electric heat pumps, that sort of thing. So fuel switching is something I'm seeing more and more of. So traditionally natural gas has been much cheaper than electricity, but as we've seen recently in the market, since the east coast of Australia up until a couple of years ago was insulated from the international market, but now we have big gas refrigerators, or one in Gladstone, that they can now compress natural gas and put it on a boat and send it to Korea or China, and they will pay more for the gas than we have been traditionally paying locally. So for the gas suppliers, it makes sense for them to send it offshore rather than to sell it locally. So eventually our price should meet the international price on that, so our gas is going to cost a lot more. Also, coal seam gas has got issues associated with it environmentally as well. That's a lot of people locally are divesting from gas at the moment in order to not be partially or indirectly responsible for that environmental impact. So I guess the big thing that I'm seeing is moving away from gas pool heating to electric heat pumps. Those are more than 4 times more efficient thermally efficient than a gas heater. Sometimes up to, in lab conditions, up to six times more efficient. So any sort of, even though gas is still slightly cheaper per unit of energy, it's still much cheaper to run an electric heat pump than it is to run a gas heater. So your gas heater, if you're lucky, might be 80% efficient, whereas an electric heat pump could be 400% or 500% efficient. So in some cases as low as 12 months payback period, but normally in the 18 months to 2 years sort of range. Domestic hot water in residential strata is a lot harder to retrofit, and the reason for that is that even though the owners corporation technically owns and maintains the plant in the building, the individual tenancies or apartment owners actually pay for the fuel to run that thing. So each apartment has its own little hot water meter at either the entrance of the apartment where the hot water comes in, and the litres of hot water that they use over a billing period is added up. And also on the main hot water system, there's a large water meter on the makeup to the hot water system, and a large gas meter. And the local in Sydney, the local network provider Gemina owns all of that metering infrastructure, and they take the ratio of megajoules of gas that go into the hot water to litres that go in, and reconcile that against the number of litres that each individual apartment uses, and then bill them accordingly on that. So their retailer sends them a bill for their contribution to that hot water system. So there's a bit of a split incentive there. If the owners corporation spend a lot of money to upgrade that plant and make it more efficient, they don't necessarily reap any of the benefits from it. The individual tenancies do. So they may be lot owners or they may be renters. So it's a harder one to sell. When we're thinking about doing all of these energy efficiency upgrades, we've got to make sure that we maintain compliance to the Australian standards. And the one for general lighting is Australian Standard 1680. And for emergency lighting, it's Australian Standard 2293 and also Part E4 of the Building Code of Australia. And for mechanical ventilation, it's 1668.2. So there's some reference standards just to keep in mind if you're doing these sort of upgrades. So one really good thing that we've got going in New South Wales here at the moment is the energy saving scheme, and I think the legislation was enacted in 2009. So it's a community funded program. Everyone who has an electricity account in New South Wales has been paying into this fund since then. You probably won't see it on your own personal household bills at home, but on a larger unbundled electricity account that you might see for a large business, you'll see a line item on there for New South Wales ESS. So everyone has been paying into that this time. It's indexed every year. The retailers are required to purchase more of these energy saving certificates every year, and that drives demand for the certificates. They're a tradable commodity. They're traded on an open market, so they do fluctuate in value depending on supply and demand. They're worth up to $34 per certificate, but they haven't seen those sort of numbers for many years now. And I think, Vasilius can correct me if I'm wrong here, that if you're doing a project, the net benefit to the actual end user is probably about $12 per certificate at the moment. $12 to $14 a certificate. So
it's currently trading at 19.
Yep.
Today.
That's the spot price. So after the ACP takes the accredited certificate providers who are the ones who can connect the end user to the certificates, usually take their fees as a commission out of it. So the net, what the net value to the client, 12 to 14. So, but it's a great program. So the idea is that everyone's been paying into this since 2009, and if you undertake a certified project, then you can have some of that money back. With lighting and that sort of thing, a lot of the lighting suppliers are actually ACPs themselves, or they have an arrangement with the ACP. So very much like solar, when you get your STC discount, you don't really see the back end of it. You just pay the net price and you assign the certificates over to the lighting guy or to your solar guy with STCs, and they just trade them whenever they feel that it's appropriate. So for certain projects that you do, then you can get 10 years worth of SKeys up front, which is great. But there's also other opportunities where you can claim annually for over 10 years, so once a year for 10 years.
Tomorrow it's 7.3.
Well, depends on the space. So with lighting,
outside of Metro, so regional is still 10 years, but in Sydney, Metro it'll be 7.3 years for Strata.
But for certain things, emergency lighting has gone up to 11 years or something, hasn't it?
No, it's actually said it's gone down.
There's something. One of them has gone up, but most things have gone down. You're right. Yeah.
Industrial.
Yeah. So the deeming period for lighting projects used to be a flat 10 years, but just as of
car park, underground car park up to 11.7 years.
Yep.
But the emergency fitting went down to 7.3.
7.3.
It go ask the government why they.
Yeah, it's weird.
I don't understand it, but yeah.
And that's right. So common areas and that sort of thing. So corridors and that sort of thing. It's all gone down to 7.3 years of deeming now. So that's a new development. There's two ways to claim. You can claim after the installation or as a point of sale discount, depending on the model that's being offered at the time. And you require the accredited certificate provider to assist. And as I said before, community funded program. So there's this new thing that's happening at the moment called Power to Save, and essentially there's certain lighting projects that I guess they're standardising the approach to that. And there's also a parallel, it's mainly for businesses, certain businesses, but I think residential strata falls under that canopy of a business, a Class 2 building falls under that. So there's, my understanding is that the energy saving scheme went out to tender to a lot of ACPs and said, who can deliver this project for us? And they've selected certain ACPs in certain areas who can deliver this. In Sydney, I believe there's only 2 in the Sydney area, and so I guess they've got a standardised product offering that will cover a lot of different things. So, like for example, in an office space, replacing T8 fluoro recessed trophers with panel lights, they'll have a product that with a kind of standardised offering, and the certificate price for those particular projects is guaranteed for 12 months, for the first 12 months. So it gives, I guess, both the supplier and the consumer some certainty on pricing on those things, and it should streamline the process, is the idea, to make it easier. But there's also a parallel one for households as well. So theoretically, individual tenancies or houses and that sort of thing have been able to participate in this program, but there hasn't really been anyone servicing it. And I still don't know 100% whether there's actually anyone still servicing that yet or not. It doesn't seem like it's, to be frank, worth the hassle, I guess, for the ACPs at this point in time. So theoretically it's possible, but as far as I know, there's no one actually doing that for households. So solar power, you guys know all about solar power, I'm sure, but I'm seeing more and more of this on residential strata complexes, and payback periods as low as 4 years in some cases, 3 years in some extreme cases where it's a really simple installation and the building's on a really high tariff rate. But ideally you want to put panels on a unshaded north-facing aspect. East or west is okay, you get a little bit lower output. Don't install on the south if you can help it. You get an STC rebate, which is very similar to the energy saving scheme. It's a federal program. We're just about to go from 13 years to 12 years deeming as of 1 January 2019. So that'll go down, but the idea is that the actual supply and install cost is on its way down at the same time, and I think it's matched pretty well. But other people might have other opinions. I think even though we've been sort of dropping off deeming years every calendar year, the price is still on its way down, and it's still much cheaper than it was several years ago. So. There's great new technology, it's not that new anymore out there in the market, things like micro inverters and DC optimizers that if you've got issues with shading, you can actually, instead of having a string inverter, you can have an inverter on each panel or an optimizer on each panel, so that if that particular panel gets shaded, then it doesn't take out the whole string. So there's smarter ways to use the solar. It's slightly more difficult on buildings that are 6 stories or more because you've got to get cranes in, and that's expensive. And can you get access to get a crane in? Do you have to block off the street? It gets fiddly, but there's certain solar providers out there who aren't afraid to lug them up fire stairs and go onto someone's balcony and pass them up that way. I've seen that before. Talk to the guy in the penthouse suite, and here's a case of beer. Can we come through your apartment and hand them up that way? And that'll save one. Yeah, well, you take the lift up to the top floor, but get them up there. Most buildings, the lift only goes to a floor, and then there's usually a plant room floor above that, and you've got to go up the stairs. And sometimes you've got these tiny little access hatches that are just too small to fit a panel up, sort of diagonally through, and it's kind of painful in that way, but there's usually ways around it. So yeah, the payback 2 to 5 years is pretty average at the moment. Batteries, battery systems. I'm seeing, I've seen a couple of sites where batteries would pay for themselves in 6 years. So it depends if you're taking advantage of the time of use tariff and you look at how much electricity you're importing from the grid during peak billing periods and just target that and have your battery designed, your battery system just to service your peak load, then yeah, you can have a battery that'll pay for itself in 6 years or less in certain cases, which is within the 10-year warranty period. But otherwise, if you're sort of trying to service your entire demand, then I'm seeing sort of numbers in the sort of 15 to 20 year bracket payback period, which is far more than the warranty and the design life of the battery. So not really a great idea in that case. But yeah, I think we'll see that fall off, but not as rapidly as everyone thought, I suppose. Okay, water. Water is interesting for most strata buildings in that any building built before November 2014 would typically only have one water meter for the whole building, so 1 meter outside. Individual tenancies aren't sub-metered for their water consumption, so I guess most people don't really know that, but and it's probably a good thing they don't, because otherwise there's no real financial incentive for anyone to save water in their building if their neighbours wasting heaps of it. So that's a bit of a challenge. Interestingly as well, that you might think that swimming pools and gardens and that sort of thing use the most water in a residential strata complex. It's not the case. 90+% is used inside apartments, and that's the majority of that is due to leaking taps and toilet cisterns and high flow shower heads, but also in the City of Sydney LGA, especially within the inner city and around here, overcrowding of those apartments, where you've got far more than standard occupancy per apartment. That is a big thing, and there's not a lot you can do about that in terms of consumption unless you reduce the number of people that are in there. So we try to benchmark these buildings on consumption per bedroom per day, and the number of bedrooms is a proxy for occupancy. So less than 200 is best practice, 200 to 300 is a typical sort of consumption, and 300 is high use. We've seen buildings as high as 750, I think. 1600. Which one was that? Can't name names. Yeah. 1600. Wow, that's insane. Yeah, that's really big. I thought 750 was bad. So yeah, there's lots of issues to be done there, but lots of opportunity as well. Now Sydney Water have got this great program called Water Fix, and I'll talk about that in a little bit more detail in a minute. So challenges for trying to make all this sort of stuff happen in Strata is that you've got several decision makers instead of one. You might have 500 decision makers if they all show up to a general meeting to vote on something. And a lot of the time the decision makers lack technical or business background, so they can be making decisions based on instinct rather than fact. That's a problem. And also there seems to be a bit of aversion to opportunities with more than a 2-year payback period, particularly for investors. If they're thinking I'm just in this for the capital gain and I'll get out at some point, they're not wanting to spend any money on saving money in the long term. There's also a lack of financial incentives compared to other businesses. There's more programs, I guess, and more incentives available for small business. And yes, you require that in certain cases. And actually, I don't know that this is really a hindrance anymore. I think it's probably more of a benefit than it used to be. So the legislation changed in November, not last year, the year before, was it, Chris? Can't remember. Yeah, 2015. So you need in order to alter common property, you need a special resolution at a general meeting. And that used to be a pain, but now it's kind of, in a way, it's kind of good, because if not more than 25% of people say no or vote against the resolution, then it's passed automatically. So if people don't show up, or if only the people who care about things show up, and not more than 25% of them are against it, then you're in. So I think it's probably, I don't know, it's probably debatable as to whether it's better now than it was. So there's also some good local government assistance around this area. City of Sydney's got some great programs running, the Smart Green Apartments program, and Vasilius and I are working on that. That date is not actually, yeah, so the current round just closed at the moment, so there'll be another one opened again in 12 months' time. There's also some really good grants. They've got a parallel program running where they offer grants for a very similar offering to the Smart Green Apartments. So with Smart Green Apartments, we look at energy, water and waste, so a massive program attacking all of those things. But if your building doesn't qualify for Smart Green Apartments for any reason, you can also apply for a grant. And there's 4 of those grant rounds a year. There's heaps of those grants. You can also get a free data logger for your water meter, which is a good thing because at the moment you might get a water bill once every 3 months, a quarterly bill. And if you've got a bad leak that nobody knows about, it'll be potentially up to 3 months until you know about that. So they've got these loggers that you can put on, and you get real-time data or 15-minute interval data, and you can set little alerts on there to send your building manager an SMS or an email or something saying, hey, something's not right here. We're using much more water than we normally would. So that's a good thing as well. Ku-ring-gai Council have got their Smart Units program. I probably shouldn't quote me on those actually, these figures here. I'm not sure what their offering is at the moment, but I think that hasn't changed. North Sydney Council are about to start another program that's kicking off pretty soon, I think, but just have a look at the North Sydney Council website if that's applicable to you. There'll be something on there about that. So just back to WaterFix quickly. This is basically a fully project managed thing that Sydney Water are offering, where they'll come in and they've got a project manager involved. They'll line up all the visits to the apartments and everything, but they want to go in and go to every single apartment and fix all the leaks, change the single flush cisterns to dual flush, replace any old shower heads that are really high flow with Wells rated shower heads. And they also will put a flow regulator in the kitchen tap and the hand basin as well, so that you're not just blasting water out at ridiculous volumes. And in certain buildings that use more than 500 litres per bedroom per day, they'll actually fully fund that program, and essentially it's like sorry, the term escapes me at the moment, but essentially they'll fully fund the cost of it, and you just pay for it in your water bills over time. So they'll do the work, but your water bills will stay the same for about 12 months until you've paid off the cost of the project, and then you'll see the drop. So that it's cash flow positive. You don't actually have to fork anything out for those buildings that are really high on the benchmark. But for others, they'll work out a price for you to do it as well. So that's worth investigating if your building is using a lot more water than the average. Here's a couple of case studies here I thought I'd throw up. This one's in Chatswood, 14 Brown Street, 255 apartments built in 2001. They did a large-scale LED lighting upgrade for their common areas and using sensors where they could. So in the car park and fire stairs, each light has its own sensor. When no one's around, they dim down to about 20% of full power, and when motion's detected, they power back up again. In a fire stair, that's like 90+% savings over the fluoros that run 24 hours. They put carbon monoxide sensors to control their car park ventilation fans. They were 75 kilowatt fans they had, 175 kilowatt supply and 175 kilowatt exhaust. So those things were, you can see, actually, I'll just go over here. There's the car park exhaust fans running in the morning. So putting on the carbon monoxide sensors, it went down to this sort of load profile, and they also put a variable speed drive on their condenser water pump, and a power factor correction unit. we reset the peak capacity charge after we did all this, and as of, I think, last year, they were saving $87,500 in electricity and lots and lots of tonnes of CO2 equivalent. So yeah, that's what their load profiles changed to. There's the condenser water pump and the variable speed drive on that. Made some good savings as well. Zinc apartments. This one, they've done lots and lots of things. They've upgraded all their lighting to LED, and they went above and beyond. These guys, they actually put a solar system on that was bigger than they needed, and they export to the grid 9 months of the year. But they're on a tariff rate that supports feed-in, so they get 12.5 cents a kilowatt hour back for what they put back into the grid. I think the installer was offering a bigger system for no extra money, so they thought, why not? We'll just do it. We'll subsidise our neighbours' consumption. That's right, only for common areas in this case. And that's the case for most apartment buildings, is that there's, especially medium to high rise, there's just not enough roof area to do the individual tenancies as well. But in this case, there probably is actually. They probably could do some tenancy stuff as well. But the issue becomes the Australian standards, and Ausgrid take a particularly, I guess, rigorous view on this, is that if you have more than 30 kVA of solar connected to the same network connection point, then you have to have